So let us check DFT in VLSI from basics to future trends. So what is DFT in VLSI? So basically DFT is the design for testability. So it refers to the techniques and the methodologies which are used to make an IC easier to test for our manufacturing defects. So it is a technique basically which facilitates a design to become testable after production. Since modern ICs are highly complex, testing of each and every individual transistor and connection is impractical. So DFT ensures that the faults can be efficiently detected and diagnosed. So let us know, why do we need DFT in VLSI and what's the use of DFT in VLSI? So as VLSI circuits becoming more and more complex, testing them efficiently is quietly a major challenge nowadays. So it is essential to ensure that manufactured chips are free from the defects and they function correctly, because post-production testing is necessary here, which involves the process of manufacturing is not 100% error-free. So this is the place where DFT plays a major important crucial role, and these are the reasons why DFT is needed in VLSI. The first reason will be the complexity of the modern ICs. So in today's modern chips, which contains the billions of transistors, making the manual testing is impossible. So manufacturing defects are also unavoidable, like IC fabrication involves extremely small feature sizes like nanometer scale. So here are some of the common defects, which includes staccato faults, bridging faults, open circuits, and then timing faults. So third reason is reducing the test cost and the time. So let us check. DFT ensures these defects are quickly detected and they can be isolated. So let us test a chip without using the DFT technique, and the result is it provides exhaustive testing which makes too long and is very too expensive. And if we perform the same testing with the help of DFT of the same chip, we can use the techniques like scan chain, ATPGs, and reduce the test time while achieving our high fault coverage. So the next crucial need is improving the yield and quality. See, higher yield means more working chips per wafer, so which improves the profitability and enables debugging and failure analysis. Post-silicon debugging is easier with DFT features like JTAG and BIST. So engineers can analyze failing chips, identify the root cause, and improve the manufacturing process. So the last need is essential for advanced technologies like AML and 5Gs. So nowadays AML chips and high performance processors demand robust testing due to their complexity. So in conclusion, we can tell what's the need of DFT in VLSI is, DFT is not an option in modern VLSI. I can tell it's a necessity for ensuring the chip quality, which reduces the test cost and improving the manufacturing yield. So without DFT, large-scale production of these reliable chips would be rarely possible. So let us know, what is the role of a DFT engineer and what does actually a DFT engineer do? So DFT engineers is responsible for making sure that the complex VLSI chips are testable after the fabrication, and the main primary goal is to design and implement the test methodologies to detect the manufacturing defects. So here are the key responsibilities of a DFT engineer. So the first responsible is he should look into the DFT architecture, so which is the planning testability features during the design phase itself. The next responsibility will be scan chain insertion. So implementing the scan based test methodologies by using scan chain methods. The third one is ATPG, so which is automatic test pattern generation, which is used to generate the test vectors by applying some inputs in order to get the outputs. So which are stuck at, transition and path delay faults. So the next is JTAG, that is boundary scan, implementing and validating boundary scan chains. So the next one responsibility is BIST design, so which is built-in self-design. So in this design, so the chip itself tests itself, and it is one of the embedded testing, so which is used to implement the logic or memory-based solutions. So the next responsibility is DFT verification and validation. So in this process, the DFT engineer ensures scan-based testing, MBIST and JTAG functionality, so before tape out of any particular chip. And the last responsibility is post-silicon debug and the yield improvement. So collaborating with the automated test equipment team for the failure analysis. So let us check what are the challenges faced by the DFT engineers. The first and foremost challenge is increasing in the design complexity. See, modern SoCs contain billions of transistors which are wafered in the single chip. In like advanced nodes like 5 nm and 3 nanometers require new fault models. So the second challenge is test pattern explosion. So ATPG generates millions of test vectors leading to increased test data volume. So we can use the test compression techniques which are essential to reduce the ATE memory usage. And the third challenge is power constraints during testing. So at speed testing, it consumes more amount of power which causes higher drop issues. So due to this, the low power DFT methodologies must be implemented. The next challenge is timing closures. So scan chains introduce additional paths which impact timing. So proper scan chain balancing is required to meet timing constraints. And the last challenge is debugging of silicon. So post-silicon features or failures may not always match pre-silicon simulations, because here we need collaboration with ATE and the project engineers in required for root cause analysis. So these are the challenges faced by the DFT engineers. So let us check in the future scope of the DFT engineers. So DFT continues to evolve with advancements in the semiconductor technology. So these are the key futures trends include AI, ML and DFT. So usage of AI, it prevents the test pattern and optimize the reduced test time. So by using machine learning, which aids in fault analysis and yield our improvement. So the next scope will be 3D IC and advanced packaging. So here DFT methodologies must adapt to chiplet based architecture, and new testing strategies are required for heterogeneous integration. So the next will be the advanced fault models. So beyond traditional stack-out and transition faults, new fault models for FinFET and 3D transistors are emerging. And the next future scope of the DFT engineering is power. So techniques like dynamic voltage scaling plays a crucial role in low power chip testing. And the last future is high speed interface testing. So which is a growing demand for high speed SERDs, PCIs and DDR, which requires enhanced DFT techniques for high speed I/O testing. So let us check what's the roadmap for becoming a DFT engineer. And here is a step-by-step guide. So first we need to build a strong fundamentals in VLSI in digital electronics, like having a basic and a strong knowledge from combinational circuits, sequential circuits which includes flip-flops and FSMs, etc. So we need to understand the CMOS VLSI design, operations of the MOSFETs, CMOS, transistors, power analysis, etc. And we need to have a knowledge on HDL languages like Verilog, System Verilog for RTL design. So next step, so learn the DFT concepts like scan chain, ATBVs, BIST, JTAG, and the fault modeling. And we need to understand the DFT architectures which are used in ASIC or SoC design. So the next step will be the hands-on experience with the EDA tools. Tools like Synopsys DFT compiler, TestCent, and the JTAG testers. So we need to have some experience in order to gain the knowledge on EDA tools. So we need to work on DFT projects like implement the scan chain insertion on ATPG for a small design, or else simulate the stack cut and transition faults testing using industry tools. And the next step, we can gain industry experience by applying for internships in semiconductor companies. So where you need to work on post-silicon debugging and yield analysis. And the last step is keep updating yourself by learning in the career of DFT. So learn about low power DFT, AI driven the test optimization, advanced fault modeling, so which leads the transition into the roles like DFT lead, test architect, or yield engineer roles. So let us come to know how DFT engineers contribute to the semiconductor industry. So it helps in detecting defects early, reducing the chip failures, so which ensures manufacturability, improves production efficiency and minimizes the test cost, which optimizes the yield and cost. So enables testing of next gen AI, 5G and automotive chips which support advanced technologies. It works closely with RTL designers, verification designers and test engineers to bridge design and the testing team. So this is how the DFT engineer contributes to semiconductor industry. And let us look what are the career opportunities and what are the roles in the DFT engineer. So the basic DFT engineer, so we can become the ASIC test engineer, test architect engineer, silicon validation engineer. In silicon we have pre-silicon, post-silicon. So memory DFT engineer like M-based, L-based, and also the product engineer. So let us check into the companies which are hiring for DFT engineers at 20-25% is like Intel, Qualcomm, NVIDIA, Google, Broadcom, Synopsys, and etc. So there are many companies which hires DFT engineers. And why we need to choose the DFT as a career for a VLSI professional. So choosing a career in DFT is a rewarding decision. So in other words, we can tell it's a powerful decision due to its growing demand and technological advancement around the environment by us. So here are the some reasons why DFT is an exciting and promising career choice. So high demand and industry growth. So there will be a strong career stability and compensation. So contribution to cutting edge technologies, and we can have the wide opportunities for innovation and learning. So let us see the final thoughts. So I would say a career in DFT is promising as testing is a critical and a crucial step in the semiconductor manufacturing. So with the help of this AI driven testing, 3D ICs and low power DFT gaining importance. So DFT engineers will be in high demand